Now it's better? Yeah.
Yeah. Okay. I'm gonna ask you again, probably you spell, your name.
Spell.
Yeah.
And the way I spelled is okay?
Oh yeah. Oh yeah.
Yeah,
That's
yeah.
perfect. Yeah.
Yes.
Yeah. Please spell your name.
Okay, my name is Sudeep Kanungo. My first name is Sudeep. You spell it as Sudeep. And my family name is Kanungo. You spell it as Kanungo.
So yeah, please tell me like your title and also the association. Yeah.
So my title is doctor, and so I go by Dr. Sudeep or Dr. Kanungo, whichever you prefer. And my affiliation is with the University of Utah. I was in the University of Utah for many years, for over 15 years, as a researcher and academician. Currently, I'm a senior fellow in a think tank, in a political think tank in Washington, D.C. called the Atlantic Council. And it's a very large think tank. It has many functional centers, and I'm in their Geotech center as a senior fellow. So those are the two affiliations, University of Utah and the Atlantic Council.
Great. Okay. So just it looks good. Yeah. Just I wanna double check. Yeah. Okay. Yes.
Yeah?
Yep.
So today we'll talk about geothermal energy. And geothermal energy is in the news these days because it's a promising source of energy that provides a lot of support and stability to the grid, to the power grid. And I'll begin by what is geothermal energy. Geothermal energy is heat energy from the earth. It comes from two words, geo and thermal. Geo means earth and thermal means heat. And beneath our feet, so geothermal energy is also, you can also think of it as heat beneath your feet. And beneath our feet, there are reservoirs of hot water at different temperatures and at different depths. And by drilling wells, from a few feet deep to miles deep, to several miles, we can tap that heat energy and bring it to the surface and use it for various purposes. And I'll tell you what those purposes are. One of them is generating electricity. Okay? The second would be heating and cooling buildings, heating and cooling or space conditioning, which is very important. Third is you can use the heat directly, like for fish farming, for heating a swimming pool, for manufacturing industries, any industry that requires heat. And fourth is it also is useful in producing lithium, which, as you probably have heard, has a global demand now for batteries. With lithium-ion batteries that are used in electronics, they are used in electric vehicles, in electric mobility devices like scooters and bikes, and several other applications. So geothermal energy has a lot of applications in today's world which are becoming important. In terms of electricity, what we do is hot fluids are basically brought up from the earth through wells up to the surface. And then those hot fluids are converted into steam, which then spins turbines, and those generate electricity through electromagnetic effect. So that's how electricity is produced in a power plant. Geothermal electricity is produced in a geothermal power plant. For heating and cooling purposes, we use the stable temperature of the earth beneath the ground or beneath the soil, right? And those stable temperatures are in the range of 50 to 70 degrees Fahrenheit. We use that as an exchange mechanism of heat between a building and the earth. So that's basically what is for heating and cooling purposes. Then the third, like I said, is direct use. So you can use the heat directly that you bring from the earth and use it in an industry. You can use it in a swimming pool, in a spa, in a fish farm, in a greenhouse, and anywhere you can use it directly. That's direct use. And lastly, like I said, is used for batteries. So the geothermal fluids or the geothermal brines, they can be used for extracting lithium, the mineral lithium, which is used in batteries, and they are integrated with geothermal power plants. So there's something called direct lithium extraction from brines, and that happens literally in a couple of hours once the brine is ready. So those are the applications. Now, you must be wondering, when you talk of geothermal energy, you probably think of volcanoes and you think of geysers, like the Old Faithful geyser in Yellowstone Park. Most people associate geothermal with that. But geothermal is more about the Earth's natural heat, which exists in various degrees everywhere on Earth. It is not just where volcanoes are or where geysers are. It exists in some form or in some degree everywhere in the Earth, everywhere on Earth. It is closer to the surface and easily accessible in some places. For example, in Nevada, in the Basin and Range province that in Nevada, it's closer to the surface. It's closer to the surface in the Yellowstone National Park, where you have natural, geysers and hot springs. But it exists to some form, like I said, in everywhere on Earth, right? And even in areas without dramatic features like volcanoes or geysers, the ground maintains a steady, constant temperature that can be utilized as geothermal energy.
So, is it okay? Can I bring the question?
Yeah.
Yeah. So, why, you already had some kind of background for energy solution, or that's how can you really started about the specifically geo stuff?
Yeah.
Yeah.
So, typically our energy comes from coal, from natural gas, from oil. So those are the main sources of energy that are used globally. But they are carbon-heavy sources of energy, right? And because energy demand is so high, peak energy demand is so high now, and I'll come in a minute to why it's very high. Because it's so high, we need additional sources of energy. Just coal, oil, and natural gas won't be sufficient because, as you know, we will run out of them, or there will come a time when we cannot extract them anymore, right? And new discoveries may not happen. So we need additional sources of energy, and geothermal is one of them. And like I said, it's the Earth's natural heat. So it's renewable, it's sustainable, and it has very little emissions, carbon emissions. So that's why it's becoming so popular now, because it is replenished constantly, and we will literally never run out of geothermal energy because it's the heat from the earth, right? The natural process of the earth. And so the challenge now is, how do we meet this electricity, this peak demand in electricity? Keep the grid stable, the power grid stable, stabilize the grid, and also reduce emissions, ideally. And geothermal answers all these questions, and that's why it's popular, and that's why we're talking about it now. So I started with oil and gas. I started my career with that, and then pivoted to geothermal energy because I thought this is a great energy area to focus on. And Utah especially is a great center for geothermal energy.
So, that's the reason why you came to Utah, or?
I came here to work as an academic at the University of Utah as a postdoctoral. I finished my PhD from London and then came to Utah to do a postdoctoral fellowship. But that was in oil and gas, right? I started with that. I did that for many years and then pivoted to geothermal energy recently in the last 5 years.
What was the trigger for just switching?
The trigger for switching was I wanted to, my motivation was, I'm a geoscientist by training, a geologist or a geoscientist, but I wanted to expand the application of geoscience to solve larger problems related to energy. I was in the energy field before, but I wanted to solve larger energy problems and that have a societal impact, that can impact society in a bigger way. And so with this form of renewable energy, this form of sustainable energy which has very little emissions, I thought this would be a great way to sort of have a broader societal impact. And for that, I applied for a fellowship in the federal government in Washington, D.C. Through the American Association for the Advancement of Science, or AAAS as we call it. And I was fortunate to get that fellowship, and I went to Washington, D.C. to do that fellowship in 2022. And there I worked in the Geothermal Technologies office in Washington, D.C. in the Department of Energy, in the US Department of Energy. So that was the trigger, maybe.
Yeah. I heard in Japan that the geothermal is a very, very kind of next power
It is.
opportunity.
It is.
And then just after 2011, the tsunami disaster happened and a nuclear power plant, the accident happened.
Yes.
And then after that, people started going renewable energy, but very gradually they started finding that renewal mean not exactly renewal, especially for a solar grid, solar power stuff. That's they have to now just everywhere in Japan there's huge programs.
Yes.
Yeah. So but that's really interesting.
Yeah.
You choose the kind of geo.
Yeah.
Yeah.
And solar and wind are the other forms of renewable energy, right? But the problem is they are intermittent, because when the sun sets or the wind dies, you don't have solar or wind. You need batteries. You need massive amounts of battery storage to support it. Whereas geothermal energy is always on. It's 24/7, is constant, right? And you can adjust the output based on demand. So it's flexible. So we call it firm, flexible baseload power, which means it is on 24/7 all the time, regardless of weather. So that's where geothermal energy becomes very important, because it's like the quiet worker in a room who constantly keeps working while everybody is talking. It's not flashy, it's not loud, but it's happening constantly and doing the work. So that's the kind of personality. If you were to say what kind of personality would you associate geothermal energy with, it would be that kind of a worker who's working all the time, getting things done without making a noise. And that's geothermal energy. It's constant, reliable, firm, flexible energy. I hope that makes sense. And then we can also talk about why it matters now. Like I said, why is the demand now? So a big driver is the rapid growth of artificial intelligence and cloud computing, right?
Yeah, go ahead. Yeah.
A big driver is AI and cloud computing. And the demand for data centers is increasing. Data centers are here for AI, and they are increasing the demand for electricity. So because of them, we need electricity all the time. We need constant electricity, and the peak demand is increasing. And they're saying that the peak energy demand will be of the order of 700 to 900 gigawatts by 2050. Can you imagine how big that number is?
Can you explain?
Yeah. So it's a huge number. So we are talking about like 700 to 900 gigawatts. And I'll just give you an example. The data center energy use, could reach anywhere between 300 to 600 terawatt hours by 2028, just in 2 years. And that is 10 to 12% of total electricity demand of the world. If you get it. So 10 or to 12% of the total electricity consumed would be on data centers. In the United States, let's take it in the United States. Let's not talk about the world now. And that's a huge chunk. So how do we basically reach that that energy production, right? And therefore, we need additional sources of energy in addition to coal, in addition to natural gas, in addition to oil, in addition to nuclear, and geothermal is one of those firm, flexible powers, firm, flexible energy resources that you can think of. And another reason why geothermal is becoming popular is because of edge computing. Have you heard of edge computing?
Yeah, no.
It's basically a distributed IT architecture where you process data close to its source and not from a centralized cloud. And it has two purposes. One is it gives you operational efficiency and speed because you're close to the source. And the second is it gives you some level of security for time-sensitive applications because you're processing the data closer to the source and you're minimizing the data travel distance and the bandwidth and reducing bandwidth costs, right? So these forms of computing, be it AI, cloud computing, quantum computing, and also edge computing, these kinds of computing are basically increasing the demand for electricity. And because of that increased electricity demand, we are seeing there's a lot of attention on geothermal now. But remember, the main thing is it's firm, flexible power that is on 24/7. Once it's produced, you can produce it all the time and regardless of weather. So therefore, it is different. It is different from the intermittent forms of energy, renewable energy like solar and wind, right? And you can adjust its output based on demand. So it's flexible, right? And therefore, it provides stability to the grid.
Can I have a question?
Please,
Probably,
please.
Kind of, any just technology kind of big change,
Yes.
For example, used to not so much people talk about the geo, and it's just you say just kind of challenging always going on, and then that's probably some kind of technical a breakthrough happened recently
Yes.
about the geo.
Yes.
Yeah, go ahead.
Yeah.
That's a good question, right?
Very good. Yeah. So, sorry. Let me explain to you before coming to technologies, what actually we need for geothermal. For geothermal, we need three things under the earth. We need heat, which is there naturally. Like I said, the earth's natural heat is there all the time, right? We need water or fluids, and we need permeability. So the water has to, or the fluids have to be able to flow through the rocks under the surface of the earth. So we need heat, we need fluids or water typically, and we need permeability, which means how is the water flowing through the rocks under the surface of the earth. Now the water flows through the rocks and the fluids flows through hot rocks basically. It absorbs heat and then we bring it up to the surface through wells. Okay, that's how basically geothermal heat or geothermal energy is extracted. Now at the surface, the heat is converted to steam, and then steam is used to spin the turbines, and the turbines generate electricity through electromagnetic effect by converting thermal energy into mechanical energy using magnets and stuff like that. But the system, the heat is actually set up by nature. We are not providing heat to the earth. It's natural heat, so that's important. Now, in some areas of the world, for example, in volcanic margins, like you said, in Japan, or areas where the crust of the earth is stretching and thinning, like in Nevada, in the Basin and Range province, you have natural geothermal systems with surface expressions, like geysers and hot springs, and like in the Yellowstone National Park. Those we call hydrothermal systems, where basically you have all three elements, which is heat, fluids, and permeability naturally. The holes in the rocks or the pores in the rocks are connected naturally. So those are hydrothermal systems. But we can also engineer those pathways under the earth, under the surface of the earth, through fracturing rocks and create those holes for the fluids to move. And those are the new technologies that we are coming up with, which are called enhanced geothermal systems. An example of that we have a laboratory in Utah, in southern Utah, in Milford, in Beaver County, where they are demonstrating, they're doing pilot, laboratory scale demonstrations in the field on enhanced geothermal systems, and it's sponsored by the US Department of Energy. It's called the FORGE project. So enhanced geothermal energy and other technologies like closed loop systems, they basically allow us to take geothermal systems anywhere on Earth. They expand its reach from those niche areas, which are the naturally occurring areas, to other areas where we may not have those connected systems under the surface of the Earth. So those are since you asked about newer technologies, I think those are the new technologies like enhanced geothermal systems, closed loop systems, and they are called next generation geothermal technologies.
Wow, actually you're so good,
Oh, thank you.
Oh yeah.
Thank you. No, that's great. I like talking about it. I'm passionate about this field.
Yeah.
And these next generation systems, they, like I said, they can expand access of geothermal from traditional areas to new areas, where you wouldn't think of producing geothermal energy.
Wow. That's
And they also estimate that these next generation technologies, could produce as much as 90 gigawatts of clean, reliable power by 2050. 90 gigawatts. And just to give you an example, 1 megawatt MW, can provide electricity to about 1,000 homes. So you can imagine how many 90 gigawatts is huge.
Yeah. That's how what kind of system, just big huge system, or how, yeah.
So there are different scales. So you can use it for power, where this is enhanced. Next generation technologies would be more beneficial for producing electricity or power. So you would have power plants for that, and then you would have to connect the power plants that are producing geothermal electricity to the power grid through transmission lines. So power has three components. There's generation, there is transmission, and then there's distribution. So yes, huge systems, you're talking about it, but connecting it to the grid is very important for power. It's a serious expansion of our current grid, but it's already happening, and it just needs to be scaled up.
Is it already commercially?
Yes. In fact, here in Utah, we will be producing, there's a company called Fervo Energy, which will be producing commercially. They've already done their testing, and their development and all is done. Now they'll be producing commercially this year, I believe, from Utah and Nevada. It's called the Cape project, which is coming up fast. Yeah? Now that we've talked about electricity, now let's talk about heating and cooling. So the one application is electricity. The second is heating and cooling, which means space conditioning. How do we keep our buildings, our offices, businesses, heated in the winter and cool during the summer, right? And that's a huge, again, it costs billions of dollars to keep our buildings heated and cooled, heated and also cooled in the summer. That's a huge energy cost, right? So geothermal can help with that, because, like I said, just beneath the soil, the temperature of the earth is constant throughout the year. It's about 50 to 70 degrees right beneath the soil, just a few feet beneath, like from 5 feet to say 50 feet below, right? So we can use that constant stable temperature of the earth and connect our buildings to the earth through ground loops called geothermal heat pumps. So basically what they do is they move heat from the building to the earth in the summer, Okay, so it's okay. So they
Just cooling down.
yes, yes,
Oh, I see.
and then pulling it from the earth in the winter to heat the homes, and that way you use it like a refrigerator, like a giant heat regulator. So that's the heating and cooling. And then you can connect several buildings. You don't have to just use it for one building. You can use it on a campus scale. You can use it on a district scale or a city scale. And there are examples of that in the US, in Europe, where you can use geothermal heat pumps to keep our buildings heated and cooled, for heating and cooling applications. And so that is another big use of geothermal. And the third, like I said, is the direct use. You can pull the heat from the earth and use it directly for fish farming. You can use it for greenhouses. You can use it for your swimming pools and spas and recreational facilities. And you could also use it for industries. Any industry that requires heat can utilize it, and that's called direct use. So there are these several applications.
Like gosh, you must be so excited. Walking that.
Yes,
Yeah.
I think it's a great
Yeah.
it's a great energy resource, and we need to sort of talk about it because most people don't know about it or don't know as much about it. Because when you talk of energy, people think of coal, they think of gas, natural gas, which are important, and I'm not saying, but we constantly need to add new sources. We need to, complement those existing resources with new ones, right? Because the energy demand of the globe is so high. So that's what. I think one of the things you may be questioning is, what are the strengths of geothermal and what are the weaknesses, right? Maybe you're. So like I said, the strengths of geothermal are many. First is that, it is always on, it is 24/7, right? So it's firm and it's flexible. So you can adjust the output of power based on demand. You can increase it and decrease it. For example, in the night you could decrease it, in the day you could increase. It depends on what the peak energy demand is. So it's firm and it's flexible, and therefore it stabilizes the grid. And thirdly, a geothermal plant requires a small land footprint. It doesn't take up huge space like solar does or wind does or hydropower, which is another form of renewable energy, where you have hydropower from water, flowing water. So this needs a smaller land footprint compared to other forms of renewable energy. So it needs smaller land footprint, it's always on, it's baseload power, and number three is that it is adjustable. So those are the advantages. The disadvantage or the challenges, I would say, are it is expensive. So it's a very expensive form of energy because it is very capital intensive. So the upfront costs are very high for exploration and then for production because you have to drill wells. Just like you drill wells for oil and gas, it uses the same infrastructure of drilling wells much more deeper sometimes. And not just vertical wells, but also horizontal wells. So there's, you just don't drill vertically, but you also drill horizontally typically to connect the fracture networks and do those kind of technologies, to apply those kind of technologies. And therefore it's a very expensive form of energy for production, for exploration, and also it takes several years for it to come to the market. So the production and the development phase typically takes 5 to 7 years. So it's a slow process, and it has several legal challenges as well, because it needs permitting and leasing, not just by state authorities but also at the federal level. Because typically if you were to produce it on federal land or on state land, it needs lots of permissions, lots of regulations, lots of policy governing geothermal energy, and therefore it's slow in terms of it's relatively slower to come to market for deployment, right? So those are the disadvantages or the challenges. But streamlining those policies or those permitting rules could greatly accelerate deployment of geothermal energy. For that, we need policy changes, we need policy approvals, and also legislative action in the Congress. But the good thing is, right now, Congress, there is bipartisan support on both sides of our Congress for geothermal development. So that's the good thing. And then the private sector is also very, very excited about it. For example, tech companies like Google, Microsoft, they're all supporting geothermal by partnering with utility companies to produce geothermal energy, so that they can be more secure, and they can sort of do these data centers that they're looking at.
So how the maintenance cost? Kind of once it seems like it's just
once you have a geothermal plant, I think yes, maintenance costs are not very high. You can have a plant going typically for 30 to 50 years. With maintenance, of course, so that's part of the power plant. But any power plant needs maintenance, right? But once it's up and running, I think you're good for 50 years. So that's a long, you can produce so much electricity in that time frame.
I think that's great.
Yeah?
Yeah.
You think that's good?
Yeah.
Okay, great, awesome.
Yeah.
Thank you. I really enjoyed, thank you for listening.
Yeah. Oh man, I really enjoy it. Yeah.
Thank you.
Yeah, thank you.
Thank you so much.
Yeah.